Okay, let's take a look at our third example, which, like we said earlier, as you can see from the answers, we are trying to isolate y. So whatever y is, whatever x is, normally you don't really care, especially when you have a time constraint, you're taking a test. So here we have the equation ax plus by plus k is equal to 0. And this is one of the standard forms of a linear equation. We want to isolate y. Now, if you want y, you can see if I want y is going to be here. And so obviously this k and this s will go to the other side. So even looking at your answers, you need to have a negative ax in the system, and you need to have a negative k also in the system, because this is going to move to this side here. This is also going to move to this side here. Obviously, I'm going to subtract k from here, subtract from here, subtract as from here. So I'm going to have ax and then k here. So let's go back to our answer. So obviously this answer here has a positive a, positive. This cannot be correct. I have negative a, negative k. That's fine. Let's see, negative a, that is fine. I have a, so this cannot be correct because a definitely has to be positive. So we know this, this and this cannot be possible answers. So now the issue is y is my answer, B or C. Now, as you can tell, our B here originally have our Y has a B attached. So let's put our B attached to it. To get Y, we need to divide this side by B, and then we have this side by B, and divide also this side by B. And therefore, my Y is equal to minus A over B times X minus K also over B. Now, I have this here is supposed to be divided by b, and it is not. That is why b may not be your answer. So now I have minus a over bx minus k over b, and therefore your answer is C. So that is how you isolate the variable y from this standard form of a linear equation. And this equation now is expressed in the slope-intercept form, where in this case your slope is minus a over b, and then the y-intercept, that is the point where x is equal to 0, happens to be minus k over b.